Hi everyone, so I've been asked, let's move the sippy cup out of the way of the frame. I've been asked questions about this problem, 2.36 from Giancoli. Fugitive tries to hop a train traveling at a certain speed, and we get some information. So I've been asked several questions about how to go about this problem. So here's something to get us started. Let's talk about what we know. We know the speed of the train, the acceleration of the fugitive, and we are told that the fugitive accelerates from rest, which would be a speed of 0, to a max speed, what I'm going to call v fugitive max. And we also notice that our fugitive's maximum speed is greater than the speed of the train. Let's assume, just to get us started, that he has to get up to his maximum speed and then run some additional distance in order to catch the train. So he will be getting all the way up to this speed and then having to run some more. So we need to ask ourselves, how long, and I'm talking about time, does it take to get up to the maximum speed for the fugitive, and how far, that would be the distance, does he run while doing so? Let's do those calculations first. To find the time, we'll use this expression. The maximum speed of the fugitive is going to be 0 plus the acceleration multiplied by time. We're going to solve for that time because, again, we are given those two pieces. That's just coming from that relationship. Final speed is initial speed plus acceleration times time. We'll solve for time there. Then we can find the distance by using this relationship. And where does this relationship come from? X is going to be 1/2 at squared. Well, that comes from this general expression, but we'll declare 0 to be where we start, and we'll declare our initial speed to be 0, as we were told. Then we just need to look at what we're given and say, so how far did the train go during that same interval? Well, the train's moving at a constant speed, so the distance that the train moves would be velocity multiplied by time. And now I can compare those two distances, and I should see that the train is still farther than the fugitive. So that means the distance between the fugitive and the train is now just going to be that difference. So I said x train minus x of the fugitive while accelerating. This is a long, clunky subscript, but I used that previously, right? So the distance while I was accelerating, just to clarify. So that's going to be the distance that I have now. This right here is going to be the distance that I have between my train and my fugitive. And now I just made a little note to myself, and I'll let you take care of the rest to actually answer the questions. Now the fugitive is going to close the gap at that relative speed. So what do I mean by that? That means if, let's say, the train is moving at 10 meters per second and the fugitive's maximum speed is 12 meters per second, that means the distance that I have remaining is closed at a speed of 2 meters per second. Because if they were both going 10 meters per second, well, that fugitive, right, the fugitive and the train, they would never get any closer. But when the fugitive is going a little bit faster, they're both moving. Let's see if I can make some sense. When the fugitive is going a little bit faster, they're both moving so that soon enough he will close that gap. So that difference is going to be the speed at which he closes the gap, and that should allow you to answer the two questions that are actually asked on that assignment. If you have any questions, feel free to reach out to me. Hope this video was helpful.